Good morning. Now we are having another problem using graphical method to solve the LPP problem. So the mathematical model statement goes like this. So maximize Z is equal to 100x plus 40y. So the objective function is to be maximized, subjected to the constraints 5x plus 2y less than or equal to 1000, 3x plus 2y less than or equal to 900, 1x plus 2y less than or equal to 500, x comma y greater than or equal to 0. So I have the first constraint, so that is 5x plus 2y, so less than or equal to will be taken as so equals, so that is 1000. So either by making x coordinate 0 or y coordinate 0, we are finding the other ordinate. So if x is made 0, then 2y is 1000, so y becomes 500. If y is 0, so 5x is 1000, so x is 200. So it is 200 comma 0. The other coordinate will be 0 comma 500. Similarly, taking the second constraint, that is 3x plus 2y less than or equal to, it is 900. So it is made equals 900. Now either by making x 0 or y is 0, we are finding the other ordinate. So if y is made 0, it is 3x is equal to 900. So x is equal to 300. So it is 300 comma 0. If x is made 0, then it is 2y is 900, so y is 450. So 0 comma 450. Then the third constraint, so that is 1x plus 2y is equal to 500. So it is 500 comma 0 and 0 comma 250. By making any one of the two ordinate 0, we find the other coordinate. So then we have the non-negativity constraint, that is the basic variables here, x and y, either they will take the value 0 or greater than 0. So we have three constraints here. So three lines will be drawn. So x-axis and y-axis. So the first constraint is having the coordinates 200 comma 0, 0 comma 500. So 200 comma 0, first point is made on x-axis, then 0 comma 500 on y-axis. So joining the 2 points, so that is the first constraint. So then the next constraint is having the line number 2 with the coordinates 300 comma 0, 0 comma 450. So 300 comma 0 here and 0 comma 450. So those two lines are, those 2 points are joined here. Then the third constraint with the coordinates 500 comma 0, 0 comma 250. So 500 comma 0, 0 comma 250. So those 2 points are joined. So now all the constraints once again less than or equal to. So I have to consider the feasible region such a way that the region is satisfying all the three constraints, so that is less than or equal to. So I have to consider the region such a way that so it is satisfying all the three given constraints. So this is the hatched portion gives you the feasible region. So consider all the 4 corner points of the hatched region starting from 0 comma 0. So the objective function 100x plus 40y, substituting 0 comma 0 here. So z value 0 is obtained. So then we have point B here 200 comma 0. So that is substituted here. So getting z as 20,000. Then we have corner point A with the coordinates here 125 comma 187.5, substituting them, Z value obtained is 20,000. Then we have fourth point 0, 250. Substituting them as X and Y, we are getting 10,000. So here, considering the four values of Z, we are getting 20,000 same. That is the maximum Z which is occurring at the 2 points A and B here. So Z is 20,000 will be getting at any point on the line joining A and B. So if I consider any other coordinate that is on the line joining these 2 points A and B, so I may get Z value as 20,000. If I get maximum value of Z or minimum value of Z depending on the objective function, so then we say that there will be infinite number of solutions are obtained. So by considering other points on the line joining these 2 points A and B, the corner points of the feasible region, so if I get Z value 20,000, so then we say that infinite number of solutions exist with Z maximum is equal to 20,000. So here 1 centimeter is taken as 100 units. So based on the corner, the X and the Y coordinates in the constraint, so seeing the highest value, so the scale will be decided. So here the maximum value considered here is 500 and the least value is 0. So whether it is x-axis or y-axis, so maximum value required on x-axis is 500. So I may take 1 centimeter is 100 units or 1 centimeter is 50 units. If I take 1 centimeter is 50 units, then to reach 500, so 50, 100, 150, 200. So I will require 10 points. But taking 1 centimeter is 100 units, so I may require only 5 points of 100 each. So feasible region will be chosen, that is the hatched area, such a way that so the feasible region chosen should satisfy all the given constraints. So here the constraints are less than or equal to 0. So any line you take, the area is below that particular line. So I cannot consider this part of the region because it is falling above this line. Similarly, I cannot consider this part of the region because it is crossing another constraint here. So now for this I can say that infinite number of solution exists. Thank you, friends.